Okay, today we're doing 9.5, which we will talk about ellipses. An ellipse is basically an oval. Okay, so it's like a circle, but it's an oval, so that means it doesn't have the same distance from every point like a circle does. Okay, basically what ends up happening with ellipses is that, see how you still have two squared terms, and then you have these two bottom terms, or bottom numbers. These are telling you your distances on like your x-axis and your distances on your y-axis. And these two numbers are different because you're going to go a different distance on your x-axis and your y-axis. If these two numbers were the same down here, then it would end up being a circle because you'd be going the same distance on your x and y. Are you with me on this? So if the numbers are different, it's going to be an ellipse. If the numbers ended up being the same, it's a circle. Okay, your vertices are always on the longer side of the ellipse. So an ellipse has, you know how in a circle you have a center? In an ellipse you have two vertices, but since there's basically kind of like 4 points around, because you're going each direction, yeah? Okay, the vertices are on the longer side. We'll see how this works in just a second. Ellipses should always equal 1. Notice here on the equation, remember with circles, it equaled an actual number that gave you your radius. Okay? If they don't equal 1, divide so that they equal 1. Okay. When you're graphing, on the x-axis, you go a distance in both directions, and on the y-axis, you go B. You guys are amazing. A, B, C. Okay. So, it's easiest usually to just kind of start the example so you can see what's going on. Here at the top, you have your x and your y squared terms. Remember, if something's in parentheses, it always comes out as the opposite. Do you see how nothing is with the x squared and nothing is with the y squared? Yeah. So that means that your center is
1.
0, 0 is correct. This is always going to be your starting point. So go over here to your graph and you're going to make the point at 0, 0. Okay. Your x squared, the distance you go on your x-axis is the number below, but it's always the square root. Because if you look back at your equation, that's a squared and b squared. So we take the square root of this number. So if you go, a squared equals 25, we take the square root of that and we get a equals 5. So on your x-axis, we are going to be going 5 right and left. On your x-axis. Okay, and then on your y-axis, we would just take the square root of 16 as well. You can do b squared equals 16. We take the square root, and b equals 4. So my y-axis, I'm going to go up and down 4. What did we say about the vertices? Do you guys remember?
What is longer?
On the longer one. Which one's longer?
5.
Right. The one that we're going 5 in each direction is definitely longer. So that means that my vertices are
5 and negative
5, 0 and negative 5, 0. Yes, thank you. You're welcome. Okay, and that's it.
So, there's not always going to be 0 after the 5, right?
Well, it depends. If it's like exactly on the line, then there'll be a 0, but if it wasn't.
Okay, so if it was like 5, 4, is the other one going to be negative 5, negative 4?
Not necessarily.
Oh. And
there'll be like an example kind of similar. It just depends on like where your center is.
All right.
Okay? Right, your center is not always going to be 0, 0. It just matters what's on top of your the fractions. So if there's nothing being added with the x, that's 0. Nothing being added with the y, it's 0. But like, look here at example 3. So on example 3, what would your center be on this one? 0, 2. In fact, we'll just do this problem. So this center is at 0, 2. Because remember, whatever's in parentheses, we take the opposite, right? Now this one is also, well, go make, okay, so 0, 2, where will I go plot that? Good, 0 up 2. Okay, so there's my center. So that's your starting point now. So that's like where you're going to go each direction from that point there. if you look here, it's saying this whole thing is squared. So if you were to kind of rewrite this, this is actually x squared over 4. Do you guys agree with that? So you need to be careful on the ones where they have everything in parentheses and they're squaring it, because I'm not going to take the square root of 2. 2 is the actual distance I'm going to go on the x-axis. Okay? So we would go from this point right here, going the x-axis, we would go right 2 and left 2. On the y-axis, how many am I going to go? 4. Because this, if you wanted to rewrite it, is really y minus 2 squared on the top over 16. Bless you. And so this is telling me the distance is actually that number there, 4. So we're going up 1, 2, 3, 4, and then down 1, 2, 3, 4. And then we can draw our ellipse. So where would my vertices be on this ellipse? No. So y is the longer one, right? We all agree? Okay, so one of the vertices is here and here. So this point is at 0, negative 2. Do we see that point right there at 0, negative 2?
Yes.
Okay. And then the one on top is at 0 what? 1, 2, 3, 4, 5, 6 is correct. 0, 6. So it's easiest for you to like make your points and then figure out what the vertices are just by, counting and going to that point. Okay, so we still have to go back to example 2. So there were 2 things on here that we kind of need to remember. One of them is that it should always equal 1. Do you see on example 2 how it doesn't equal 1? So what could I do to make it so it equals 1? Close. You're going to divide by 36 because this n number is the number that I want to equal 1. So we have to divide every single term by 36. Okay, so when I do that, this 4 cancels out. Good, and we get a 9 on the bottom. So I have x squared over 9 plus, nothing happens on this one, we just have y squared over 36, and then it equals 1. Very good. And nothing is being added with the x or the y on top, so my center is what?
0, 0.
Very good. 0, 0. And in fact, instead of doing like a and b, I'm going to write here x. And what's going to be my distance on the x-axis? Good. We're going to take the square root of 9, which is 3. So that means I'm going to go, good, right 3 and left 3. So from my center point, 1, 2, 3 to the right, and then 1, 2, 3 to the left. Okay, for my y-axis, I'm going to take the square root of 36, which ends up being 6. So again, from my center, I go up 6, and then down 6. And then we can draw our ellipse. Good, yeah. And so my vertices, the longer side is the 6, right, with the y-axis. And so that is 0, 6 and 0, negative 6.
Pretty easy.
Okay. Do we have any questions on example 1, 2, or 3 here?
Why is it, isn't 3 supposed to be on the x-axis?
Isn't what? Say that again.
The 3, like, move over 3 on the stone.
This is our x-axis and this is our y-axis. Okay, you guys please listen. Okay, so here is this equation. You're okay at that one, right? Okay, so see on this one how the whole parenthesis is around here. So if you were, this is really x squared over 4. So we are taking the square root of the bottom number, which is 2. But if you look at your original equation, basically this is the square root of the actual number. Because they're like putting it in parentheses and squaring it. Do you kind of see what I'm talking about? So if you want to always just change it, so that it's not, the whole thing isn't parentheses, your top term is squared and then your bottom term is the number instead of it being in parentheses and part of it's squared. You could just always rewrite it And so that's why I was bringing your attention to it, because sometimes it is confusing because you like want to take the square root of 2, but this isn't really 2, it really is 4. And this isn't really 4, the bottom number really is 16. So then that's when you get x equals the square root of 4, which is 2, and y equals the square root of 16, which is 4.
Is it always going to be perfect squared?
Not always. It won't always be that way, but I think most of the problems in your homework and on your test are. Okay, other questions about any of these examples? Okay. Did you say wait? Yes. All of them should be fractions. Like you end up wanting them to all be like a y squared over 16 like that. Is that what you mean? Yes, because and the square root of 1 is what? 1. So on that one, all the little conversations, please stop. All you would go is go 1 in each direction. So if there was no number on the bottom, you can always put a fraction. You can make it a fraction by putting it over 1, right? And then if you take the square root of 1, it's still 1. So you would go 1 in each of those directions. Okay? All right, are we good with example 1, 2, and 3 now? Okay, so example 4, I would like you to try this one kind of on your own, but I'll help you set it up. The first thing you should notice, though, is what? Good. And so what do we do when it doesn't equal 1? Very good. So we're going to divide by 648. And you guys can use calculators and know how these reduce, but to save you some time, this first one is going to end up being x minus 1 squared on top over, and it reduces to 9 on the bottom. 72 goes into 648 9 times. Plus, over here when we divide, 8 goes into 648 81 times. So we have, I don't know why I put that in parentheses, but y squared over 81 equals 1. Okay, so you're going to need to find your center, and then you're going to end up plotting all your points and figuring out what your vertices are. Okay? So when you get your answers, you can write them on your whiteboards, or I can kind of come around and check. But I'm looking for your center and your vertices. Your center's right.
And there,
The vertices are wrong, but your center's right.
it's the same what? I got a weird.
Your center's right. Yeah, all of yours are right.
Am I right?
Yeah.
Yeah, but how do you list the vertices now?
Well, which one's the longer side?
9.
The 9, right? So it's your this top point and bottom point. So when you go to find what this order pair is, it goes 1 and then up 9. So it'd be 1 comma 9.
Yeah, but isn't there 2 vertices?
Yeah, and then you do the same thing. Go to the, so you, again it'd be
Yeah, but
1
this one
and then
would be
negative
1
9.
negative 9.
Right.
So that's the 2 answers.
Yeah. Yeah. There you go. Hold on just like 1 second. Perfect. Good.
Oh, the vertex is 1 and 8 on that. How did you get 1? Like moving.
Houses?
Like where is this? Like how this went on.
You always start from the center and you should work up 9. And then down 9. Right here. You're always starting at your center. You're not starting from 0, 0. You're always starting from your center.
Do you always have vertices? Like the x and the y and vertices?
Yeah, because your vertices are ordered pairs. So you always have an x and y value for your vertices. Okay, so your center, opposite of what's in parentheses. So opposite of what's in parentheses. So my center is 1, comma 0. So we go 1, 0. There is my center. This is my new starting point. It's not at 0, 0. It's not at 0, 0. My starting point now is at 1, 0. On my x-axis, I'm going how far? What's the square root of 9? 3. So from this point right here, I'm going right 1, 2, 3, and left 1, 2, 3. Do you guys realize that? It's not from 0, it's from the center. Okay, so then on the y, we are going the square root of 81, which is what? 9. So again, from this point, I'm going up 9, and then I'm going down 9. Now, which one is the longer side?
9.
The one with the 9. So, this ordered pair right here is at 1, 9. This ordered pair down here is at 1, negative 9.
The vertex is always on the other side.
Yes, the vertex is always on the longer side. Okay, questions? All right, example 5. They want us to put these in standard form or descriptive form, okay? So, what do you think we're going to have to do? We're going to have to, we've been doing it on all the other problems.
Combine.
Complete
Complete the factorization.
complete the square. So we need to put our x's together, our y's together, and then you're going to have your regular number on the side, and then we'll end up dividing by 1. You guys with me? Okay, so see how we have the x's? Yes?
Wait, can you divide the whole thing by 4? Or no?
We're going to wait, okay? But yeah, you probably could have done that, but we're just not going to worry about it. Okay, so the first thing I'm going to do is deal with my x squareds. Remember that when we're completing the square, we do not want a number in front of the x squared term, right? Okay, so what am I going to do?
Divide by 16.
Okay, so we're going to go 16, and then I'm going to make a parenthesis, because 16 is what is in front of the x squared, and I don't want a number in front of my x squared. Are we okay with that? Okay, so then I'm going to write x squared, and then because I'm dividing this by 16, I'm also going to divide 96 by 16. And 96 divided by 16 is 6. So I get x squared plus 6x, and then what's next? Good. Plus your blank. Okay, then we go to the y squareds, right?
And you don't want that 4.
And we don't want the 4 in front, so what do I do?
You divide by 4.
Good. So that means we're going to go 4 parenthesis, because 4 is what's in front of my y squared. And I'm going to divide each of those terms by 4. So what ends up inside here?
Y squared minus 12y.
Very good. Y squared minus 12y, and then what's next?
Plus blank.
Very good. Plus your blank.
And then outside you have to put plus 32.
Okay. So then I'm going to go equals, because I want all my other numbers on the other side of the parenthesis. On the other side of the equal sign. So what happens when I move that 32 over?
Negative 32.
We get a negative 32. And then dealing with these blanks, what do I put on this side? Plus. It's going to be plus because if you're doing it on opposite sides of the equal sign, you do the same thing to both sides. Okay? So, but I have a 16 times the blank. Some of you on your quizzes, those of you that turned it in, forgot when you had a number in front of the blank that you had to make sure you had a number in front of that blank on the other side. Okay, so we have 16 times blank, and then we have plus 4 times this blank. So I'm gonna stop here for 1 minute in case anybody has questions about any of the work that's been completed so far. So are there questions about anything to this point? Yes?
Why would it be plus 16 blank plus 4 blank instead of
So if you go back to like our parabolas, and I can show you here real quick, when we were putting our parabolas into our descriptive form, we did have 5 times the blank and negative 5 times the blank. What do you notice about this equal sign? Do you see how like these numbers are both on the same side of the equal sign? So when you have something on the same side of the equal sign, you have to add something and subtract it to make a balance. Okay? Well, on the problems that we're dealing with now, we're putting things on opposite sides of the equal sign. And so, since I have one blank on this side and one blank on this side, I'm doing the same thing to both sides in order to balance it. Okay? Other questions? No? Okay, so what's my next step here? Good. 6 divided by 2 is 3, and then 3 squared is 9. So 9 goes into each of these blanks. Okay? What do I do on this one now? Same thing. So we go negative 12 divided by 2, which is, and then negative 6 squared is positive 36. So 36 goes into each of these blanks.
Oh, so you take the half of it and then square it to get the thing.
Yep. Any questions right here? Okay, so now, don't forget, we have the 16 in front, and then what's going to be in my parentheses? X plus 3. How do I know it's x plus 3 squared? Good, you always take whatever that half number was. Whatever number is there that we end up squaring, that's the number that goes in my parentheses. Okay, so now we go to my y's. I have plus 4, and then what's going to be in my parentheses there? Y minus 6 squared.
Because it has to equal to positive and multiply to positive.
Right, it'll end up multiplying to be a positive, but whatever that half number is, if it's negative, positive, that's what always goes in that parenthesis. Okay, equals, and then we have to simplify all this and make it one term. Okay, so I have negative 32, and then 16 times 9 is 144.
I did that in my head.
Good job. And 4 times 36 is also 144.
Oh, nice.
So when we add all that up together, it ends up equaling 256. Because we're adding the two 144s and we're subtracting 32. So this equals 256.
So then you just divide it by 2.
Exactly. And so this is actually standard form, but everything we really, even though it said standard form, it should be descriptive form. We always want it to end up equaling 1. Okay? So in order to get rid of this 256 here, what do? Divide everything by 256. Okay? And so when I end up doing that,
That equals
16 cancels. 16 goes into 256 16 times. So we get x plus 3 squared over 16 plus, here 4 goes into 256 64 times. So we get y minus 6 squared equals, over 64, and then it equals 1. And so this is your final answer.
I'm gonna see squared over what?
I need to stretch too, okay?
This equals 1.
Okay. All right. So it's a little bit of work, but if you take it one step at a time, it's not horrible. Just takes a little time. Okay, so example 6. Again, we're going to do the same thing. So we're going to put our x's together. So what am I going to take out? What's going to go in front when I'm putting these together?
36.
Good. So we have 36 parenthesis, and we're dividing each of these by 36. So that means I'm going to end up with what in the parentheses?
X squared plus 24.
I think it's 4.
Yeah, that's 4. Sorry. I guess.
Yeah, it is.
Okay. Good. Plus 4x, and then what?
Plus blank.
Good, plus my blank. Now what am I going to do with my y squared?
Nothing.
Well, I still have a plain y. I just don't have to take a number out in front with the y squareds, do I? So we're just going to go plus, and then we're going to have y squared plus 14y plus what?
Blank.
Blank.
Equals
Okay.
131.
Good. Equals 131.
36.
Very
times blank.
Good. Plus 36 times my blank
Plus blank.
plus blank. Okay, so do we all understand why we don't have a number in front of the y squareds? Because there wasn't a number in front here. Okay? And then with the x squareds, we took out a 36 because we're always taking out whatever number's in front of the squared term. Okay, so now what am I going to do?
Find out the thing.
Good, find out your blank. So 4 divided by 2 is 2, and 2 squared is 4. Okay, so 4 goes in each of the blanks for my x's. Now for my y's, we take 14 divided by 2, which is 7, and 7 squared is 49. So 49 goes in each of my red blanks for my y's. So when we write this now, I have 36. What's going to be in my parentheses with my x's? Good. X plus 2 squared. And then we have plus, and what's going to be my y's?
Y plus 7 squared.
Did I do something wrong?
No.
Okay, sorry. Y plus 7 squared equals, and then we have to simplify all of this. So you have 131 plus, and 36 times 4 is 144 plus 49. And when we add all that together, $324. Okay, and then what do I do? Good. We divide everything by 324 so that it equals 1. Okay, and 36 goes into 324.
9.
Very good, 9 times. So we have x plus 2 squared over 9 plus y plus 7 squared over 324 equals 1. What would have been my center on this problem? Good, -2, -7. And my vertices would be on the x-axis or the y-axis?
Y.
The y-axis. And how do we know they're on the y-axis? They're on the longer side. Very good. Okay, so let's just recap here for example 7. How do I know if something's a parabola?
One term.
It has one squared term. Okay, now circles and ellipses both have 2 squared terms. How do you think I can tell the difference between an ellipse and a circle? Good. So a circle would have the same numbers in front of the x squared and y squared, where an ellipse will have different squared terms. Okay? So what is A going to be?
Parabola.
A parabola. And again, how do I know it's a parabola?
It has one squared term.
One squared term. Okay. B, what is this going to be? How do I know this is a circle? Good. Both of the numbers in front of your squared terms are the same. If those numbers are the same, it's a circle. Okay?
What's the last one?
So the last one is your ellipse. And if you notice your squared terms, the numbers in front of them are different, which is going to make it an ellipse. Okay, any questions?